Hello, I'd like to talk to you about discounting and also cost-benefit analysis. Let's say you have this question. You're asked to calculate the net present value for a cost-benefit study. You're given the following costs and benefits. Dollar values are in millions, so all these numbers here, and not all of them, but the 0, 12, 12, 6, 16, 16. So this is 12 million, 12 million. Over here we have an initial cost of 20 million. Now we're going to be looking at 7% discount rates and a 3% discount rate, and we'll talk about a little bit how we get those. So we also are looking at year zero would be today. So today we're spending $20 million to build this project. 10 years from now we get 12 million. 20 years from now we get another 12 million benefit. But we also have those $2 million worth of costs in the future to maintain the project. So let's first of all calculate our net benefit. Also, I should mention, let's put up our net present value calculation just to make it clear. Let's use, what color did I get here? Looks like I got red. So we're going to be looking at the summation. We're going to add them all together. So we're going to take our total benefit minus our total cost divided by, we have to discount it because money today is worth more than money in the future. So we want to have 1 plus R, where R will be our discount rate, times the number of years. So first of all, let's calculate this top part. So we have 0 minus 20 is what? Minus, see if it will stay here. 12 minus 2 is what? 10. 12 minus 2 is another 10. Then 16 minus 2 is what? 14. And then at 16 minus 2 is another 14. Okay, we have our net benefits. Now we need to discount it. So we have the top part of this equation. Now we have 1 plus R. R is going to be 0.07. Don't put 7 because that's 70%. So 0.07. N will be the number of years. So our first calculation will be negative 20 divided by 1 plus 0.07 raised to the 0 power. Now if it's raised to the 0 power, that just means it's 1, so it's just going to be negative 20. But if it's raised, next one will be raised to the 10th power. So it's, but let's clear this. Oops. So let me rewrite this. There's negative 20. But I want to erase this. So I'm going to actually all we have to do is get rid of that, get rid of the negative sign, and get rid of the, and also change this to, I'm going to change that a little bit. So let's change the next one. We have 10, so 10 goes up on top. Year is 10. So if I take $10 million, divided by 1 plus 0.07 raised to the 10th power, I calculate that it's about 5.08. And let's put, since it's a positive number, and I guess I could have made this 10, 10, 14, and 14 as positives, but I didn't. Next one, now I'm going to do 10, but it's going to be raised to the 20th power, so this would be a 20 up here instead of a 10. So actually, let's make it a little clearer than that. So let's delete these numbers. So notice it's same thing, but now this is going to be 20. So because I have 20 over here, change that back to green. And it looks like about 2.58. Once I put it in my calculator. And then I do it 14 divided by 1 plus 0.07 raised to the 30th power. And in fact, let's just do that again. So now we're going to be doing, oops, there, just get rid of that. So this is now going to be 14 raised to the, what is that, 30 over there? Well, 14 divided by 1 plus 0.07 to the 30th power. I calculate that it is, what do I calculate that it is? About 1.839. So 1.839. And the next one I calculate it to be about 0.9349. Make that 9 look a little better. 0.9349. So, you know, this $14 million, 40 years from now, so I'd have 14 raised to the 1 plus 0.07, and then I'd change that to 40 right there. Well, that's worth less than $1 million to me today, because 7%, 40 years from now, that's a few years. So it's going to be much smaller versus this 10 million. 10 years from now is worth to me today 5 million, a little over $5 million. Let's do the next calculation. And so next calculation, let's get rid of the top. It's fun to be able to erase some of your work, isn't it? Okay, I tend to be excited about small things sometimes. Okay, now we're doing the same thing for 3%. Well, this is going to be 0.03. Oops, stay in there. There we go. It's going to be negative 20. So that is, we're going to take that net benefit divided by 1 plus 0.03. First one, we're going to take it to the 0 power. Anything to the 0 power is 1. So negative 20 divided by 1. Negative 20 again. Amazing. Now, it's not negative 20 anymore. Let's get rid of these. Oops. Okay. Now we're going to 10 years from now. Let's change it. So it's going to be 10 years from now. There's 1 plus 0.03 is going to be raised to the 10th power. We have a net benefit of 10, positive 10. So we're going to just put 10 with no negative sign in front of it. We could put a positive sign, but we'll just assume that's there. And I calculate 10 divided by plus 1 plus 0.03 is 1.03 to the 10th power. So we calculate this whole thing. When I do it, I calculate 7.44. So if you discount using a smaller number, 3% rather than 7%, we have the same 10. But at 7%, I only value it a little over 5 million. Here I value it over 7 million because I don't discount it as much. Money in the future is not, it's discounted at a smaller value. Okay, next case. Now I'm taking the 10. 10 stays up on top. Now I'm doing it for what, 20 years? So we just would change that. Oops. So we change the number right there to 20. Does that look like 20? Hopefully it looks like 20, because it is. Okay, so now 10 divided by 1 plus 0.03 to the 20th power is, I calculate 5.53. 5.5368. And then on the next one I calculate to be 5.7678. And then the next one I calculate 4.2 0.29. Now the question is, let's add them all up. I'm going to put that, change the color. If I add all those up, I calculate it's negative 9.5, roughly 6, let's say, rounded. And this is positive 3.037. Supposed to be a 7. Okay, so once it's positive at 3%, I value these future, there it is, I value these future benefits higher. And so I'm going to get a more larger number. If it's 7%, I discount the future more heavily. And so in this case, this net present value of 3 million, a little over $3 million. This is net present value of negative $9 million. In fact, almost $9.56 million. So this would not be acceptable. This one would. Well, how do you get the 3% and 7%? Well, what normally happens is the 7% would be closer to our opportunity cost rate. In other words, but let's do a quick diagram here. So in this case, we have savings and investment. I'm going to put S and I. S for savings, I for investment. Up here, we're going to have our discount rate. And let's say here's our supply curve of savings. I'll put I for investment. So in this case, we first of all have, let's say, 6%. Then we have taxes. And the taxes means my take-home rate, tax on investment, means investment projects by companies have to get higher than 6%. Let's say it's 7%. But then because of the tax rate, let's say I only get a take-home amount of 3%. Well, the 7% would be our opportunity cost rate. This would be how much, if it's if this is a government project, this would be how much private companies have to earn. 3% would be kind of the time preference rate, because this is how much consumers get to take home. And so if this is coming out of if I want to compare it with private investment, I'd have to compare it with a negative 9.56. 3%, that would be comparing it with, this would be how much I get to take home if the investment project I personally get to spend. And then that's going to make the project look better, because most of the time costs are going to be up front to build the project, and then I get benefits in the future. So a lot of economists actually say we should take a weighted average of 7 and 3%, because they feel like 3% is too low, because the higher the tax rate, the bigger the difference between the 7 and the 3%. But at 3%, we would tend to say it's okay. 9%, I'm sorry, 7%. This case, because it's a negative number, that this project is not worth it. If we take the weighted average of the 7 and 3%, then it's somewhere in the middle. So we'd have to calculate that other number. So that's how you do a net present value. Hope you enjoyed it, and talk to you later.